Okay, so this video is basically going to be covering the separate example that we have for this week's lab. So in this example, what we're going to be talking about is a cone. And this cone is going to be sitting on our horizontal plane, and it's going to be then tilted up at 30 degrees, only touching the horizontal plane at one particular point of the base circle. So to basically break down this question, what we'll do first of all is we'll have a look at what the question is asking. So given the plan of cone of diameter 50 millimeters, so that's the base circle here, the diameter from side to side is going to be 50 millimeters, altitude 16 millimeters, so that's going to be from the apex all the way down to the base cone like so. Line AB rests on the horizontal plane and passes through the center point of the base circle. Okay, so we have our line AB here. It's going to be traveling through our base circle from either end like so. It's saying then incline line. Okay, incline the line AB so that it is 30 degrees to the horizontal plane with B resting on the horizontal plane. So this point B, so let's imagine this side here is B, and it's going to be touching off the horizontal plane, so that's going to be the only point of the base circle basically touching off the horizontal plane, and the rest of it's going to be then tilted up at 30 degrees. So what I expect to see when I see the cone being tilted up, so imagine this is the base circle as it's sitting down here on the horizontal plane. As it's tilting up, we'll see at the start it's almost going to get squashed as it looks when you're looking directly down upon it. The circle is going to move inwards. So like if you're looking down top this, as I tilt it up, it's like it's squashed itself inwards. So this is going to get shorter. So draw the new plan and elevation of the cone. Okay, so like the first example that I was talking about, first of all we're going to have to take an auxiliary view. So our auxiliary view is going to go out this direction, parallel with the line AB, so that we get basically a view in from the side. So as if we're standing here and we're looking in at our cone, and we're going to see that over here. When we see that, we'll be able to construct it, and then we're going to be able to rotate it after finding the center of rotation, have the new location of our cone, bring it back, draft in our plan, and then bring it up and draft our elevation. So let's kick things off. Try to be as careful as possible when you're using your sliding set squares. Just ensure that everything is kept nice and accurate. X1, Y1. Bring our lines back. Now, there was no need for me to extend that line. We're going to bring A and B over here, so I'm just going to call this A and call this B like so. Now I'm also going to locate the central point for my cone, or my base circle. To do that, I'm just going to bisect the line. Like so. Carry that over. Now I'm going to construct my cone over here. Using my altitude, which is given in my question, which is going to be 60. Like so. Knock that off and join it back. Now ensure you're keeping everything nice and light. Remember, this is all construction. Now I have to basically find where my center of my center of rotation is going to be for where I'm going to rotate my cone 30 degrees. Now I know that B is going to be staying on the horizontal plane, so that B here is going to stay in the horizontal plane. And remember, we're going to be tilted up along that line at 30 degrees. So if we're looking at that over here, that's going to be B, and it's going to be tilted up like so. So as you can see here, the center of rotation is actually going to be this point B. Like so. I'm just going to label my apex C here. C here. Just make it nice and clear where it is. Knock off my 30 degrees. Rotate up all of my points that I need. So that's basically the center of my base circle, which is here. And A as well as C. Now we know where A is going to land, because it's going to land on this line that we marked off. And we know the center point is going to be here, we marked off. But we don't know where C is going to stop, so what we have to do is get a perpendicular line from our new line here, because remember, your central point of your cone here, of your base cone or your base circle, is actually perpendicular all the way up to C, so it's going to be the same for with the new location here, so it's going to be perpendicular all the way up. Exactly 60. It is indeed. Draw the new location of my cone as it is inclined at the 30 degrees to the horizontal plane. Let's go and put this in a bit heavier so you can see it nice and clearly. Now what I'm going to do is I'm going to have a second auxiliary that I'm going to bring out here just to look at the base cone again. And when I see the base cone this time, what I'm going to do is divide it up so that I can find different points that I can use later on above here in my elevation. You'll see what I mean as I work my way through the drawing. So again, out of the way. I use my second auxiliary. X2, Y2. Oh, I need additional points when I'm breaking this up. So to do that, what I'm going to do, I'm going to half this length and half this length. So that's basically the length of AB. I'm just going to half and half it so that I have an additional point here and here to take up. So when I'm dividing up my circle. To do that, what I'm just going to do is again a simple construction, bisect my line. going to do is I'm going to get the size of my base circle just with my compass. And when I draw this circle, depending on how accurate I was, and there weren't too many build-ups of inaccuracy, they should touch tangential to the outer lines here, as well to the X2, Y2 line. As you can see there, I was very careful ensuring that everything was as accurate as possible. So you can see here it's touching perfectly tangential above here, here, as well as back here. And now also I have my divisions here, basically distances that I'll use later on above here in elevation when reconstructing this cone above here in elevation. Now to help me out with that, I'm also just going to divide this circle up using that central point. Oh, like I was saying, I'm going to basically have a circle here that's going to be squashed, okay? So as you can see here, it's A in its new location, it's actually going to move further in. So when I bring that back, A is going to be now here. And just to make that clear, I'm just going to call this point 1 now instead. Carry this one back. So what I'm going to call that is I'm going to call that let's call it 1 and 2, 1/2. Call this one 3/4, 3/4. /6, and last one I'll just change that to 7 instead of B. Do not, I'll leave it as B. So if we bring these over, so we have 1, sorry, I'll just call it A1. This is 1 and 2, so 1's going to be over here, let's say, in 2, 3, 4, 5, 6, and B again, or we'll just call it B1. We know B1's going to be sitting there, A1's going to be sitting here. We're also going to locate them over here, so let's take our distance for 1 and 2. Bring that back. Here and here. Now it's going to be close to our circle, so just be careful. 1, this is 2. This should go outside the other circle. Barely. There. And there. That's called 3 and 4. Five and 6, just outside again. Now what you could do is lightly join them all up for your new circle. Now remember, keep this all nice and light because there's going to be section, this is still going to be in detail. so. It's going to be our new circle here, our base circle. Now what we want to do is get our apex and bring that back. Now I call that apex C, so I'm just going to call it C1 over here. So there it's going to be C1. And the lines that are going to come down from C1 are actually going to touch tangential to the circle, or the start of the circle that you see below here. So what you can do is just join it down wherever you think that's going to touch, like so. And like so. Now all the lines that are going to travel in behind this, they're all going to be dotted sections, they're going to be hidden, and it's going to be nice and strong then outside here. Now what you can do is you can take each one of the base circles up. What I do is I like to start with B, because B, remember, is touching the horizontal plane, so B is going to be sitting here. Then carry 5 and 6 up. Like so. Get their distances back here. Three and 4 next. One and 2. And our last one, which is going to be A1 or A. You can join them all up. Now it's going to be freehand curves, so just try to be as careful as possible. Again, keep it nice and light. You're not too sure yet what is going to be in detail or not. Now, because the way that we're actually going to be looking at the cone itself as it's tilted in the elevation, I can tell you that everything here actually is going to be nice and heavy. There's going to be no hidden detail for this base circle. But if you're completely drawing, you're not too sure, the best thing to do is keep things nice and light, and you don't have to worry about it, and you come back afterwards. There you go. After you have your base circle, now you'll take up your apex. Get that distance. And then what you can do is join that down to the extreme, basically the most extreme point on the side of this freehand curve, so make it tangential. So, and like so. And then you have your cone here in elevation as well as in plan. What you can do afterwards, you can clean it up, you can get your rubber, take down some of the lines, make it nice and easy to see where everything is.